Section 4.6 is completing the square. I can solve equations by completing the square, and I can rewrite functions by completing the square. Big ideas here. Completing a perfect square trinomial allows the completed trinomial to be factored as the square of a binomial. An equation that contains a perfect square can be solved by finding square roots. The simplest of this type of equation has the form ax squared equals c. And the real solutions of a quadratic equation show the zeros of the related quadratic function and the x-intercepts of its graph. In example 1, we're going to solve by finding square roots. Here, if we look, we only have one x term. It's an x squared, but it's still just one x term. So we're going to go ahead and isolate that term by adding or subtracting first, just like if it was a regular x instead of an x squared. Then we have multiplication, so we're going to get rid of it by dividing. And again, whatever we do to one side, we always do to both. Now, to get rid of a square, we take the square root of both sides. And when we do that, remember that it's plus or minus 3 here. X squared equals 9. Some number squared equals 9. That number could have been positive 3, or that number could have been negative 3. Either one of those would make this a true statement. Same idea here on B. Again, we just have one x term, so I'm going to get that x term by itself by adding or subtracting first, getting rid of anything that's not with our x, directly connected. Then multiplying or dividing. Now, once I have x squared by itself, to get rid of the square, we take the square root. We're looking for what number times itself gives us 10, and that number is plus or minus the square root of 10. Again, every time we introduce a square root, we have to take plus or minus. There's two different things that we can square to get to 10. One's a positive square root of 10, one's a negative square root of 10. Now, feel free to pause here and give these a try if you'd like. We're going to get our x squared by itself by adding 10. Whatever I do to one side, I do to both. Then I have multiplication. We undo multiplication by dividing. It's its inverse operation. The inverse operation for squared is square root. So here, I take the square root of both sides, and I get plus or minus the square root of 5. The square root of 5 squared gives me 5, and negative square root of 5 squared give me 5. Same idea here for B. I'm going to go ahead and subtract 9 first to get that x squared term by itself. I have multiplication, I get rid of it by dividing. Now, to get rid of the square, I take the square root, and I get plus or minus the square root of 2. In example 2, we're going to determine dimensions here. While designing a house, an architect used windows like the one shown on the top of page 234. What are the dimensions of the window if it has 2,766 square inches of glass? So I have a sketch here similar to the picture on the top of page 234. And if we look here, we can see that we actually have two figures. We have a rectangle, and we have a half circle or a semicircle. And we know that their areas, okay, we're talking square inches, which means areas. So area of my rectangle and area of my half circle add up to be 2766. To find the area of a rectangle, okay, our formula is length times width. Here, my length, 2x, my width, x, which gives me 2x squared. Remember, the area of a circle is pi r squared. But we don't have an entire circle here, guys. We just have half of a circle. So it's half of pi r squared. Now, my radius, we don't know, but we can figure it out. Keep in mind, right now I have a diameter, And a radius is half of a diameter. It's halfway across. So if the entire way across is x, then each of my radii here are x divided by 2. So my radius is x divided by 2. Half of the distance all the way across my circle. Here I'm going to square that. And simplify this just a little bit further. I can multiply my two fractions and get 1/8, or pi divided by 8, x squared. Pi is in my numerator, 2 and 4 are in my denominator. Now, since all I have are x squared terms, I can factor that out. I can take out my common factor here and multiply by what's left. Now I have multiplication, so I go ahead and get rid of it by dividing. Be careful when you type this in here. You need to put the parentheses there around that, or figure out your denominator first and take 2766 divided by second answer. Either way, make sure that we calculate that value first. Uh, 1156-ish. It's like 0.016 repeating. So to get x by itself here and get rid of the square, we take the square root of both sides. And when we do that, we're going to get approximately 34. Keep in mind, whenever we take the square root, it's plus or minus. Now, for what we're doing with this problem, though, we can't have a negative 34. We can't have a negative distance. So as far as our dimensions go, x is 34, and these are in inches, I believe. Yeah, inches. And 2x is going to give me 68 inches. So my dimensions are 68 by 34. Okay, we're not just looking for what is x, we're looking for what are the dimensions. And we can't use the negative because we're talking about a distance, and distance can never be negative. So technically x is plus or minus 34, but as far as the application goes, we just have the positive. Now feel free to pause here and give this a try if you'd like. The lengths of the sides of a rectangular window have the ratio 1.6 to 1. The area of the window is 2,822.4 square inches. What are the window's dimensions? So here we're talking about a rectangular window. It's more of a parallelogram, but we're going to go with it. The window has a ratio of 1.6 to 1. That means our side lengths are 1.6 to 1. But they're not just 1.6 and 1. They were each multiplied by some x value that we've divided out to simplify it down. So it's 1x to 1.6x. Okay, these were multiplied by the same value to get our original ones, and then just simplified down. We know the area is 2822.4. We also know, since this is a rectangle, our area is length times width. So here, my length is 1.6x times my width is 1x, and it equals 2822.4. I can simplify here on my left side. 1.6 times 1 is just 1.6, and x times x gives me x squared. Base times itself exponent number of times. Here, we're going to divide both sides to get our x squared by itself. And I get 1764. To get rid of my square, I take the square root of both sides. And this gives me plus or minus 42. Keep in mind, though, when we actually apply this, we can't have negative 42 because we're talking about a distance here, a measurement. So I'm going to have 1 times 42, which gives me 42. These are again in inches. And 1.6 times 42, which is going to give me 67.2 inches. Because again, we're looking for the dimensions, not what's x, or what were they both multiplied by, to get back to our dimensions, or what were our dimensions reduced by, but what are the dimensions? 42 and 67.2 inches. Sometimes an equation shows a perfect square trinomial equal to a constant. To solve, we factor the perfect square trinomial into the square of a binomial, then find our square roots. So here, x squared plus 4x plus 4 is a perfect square trinomial. X squared is x times x. 4 squared is 2 times 2. If I multiply x times 2, I get 2x, and double it gives me 4x. So I know it's a perfect square trinomial. It's going to be x plus 2 squared. Okay, to get rid of a square, we take the square root. Whatever I do to one side, I do to both. That gives me just x plus 2. It makes my squared and my square root cancel each other out, and I get plus or minus 5. Square root of 25 is 5, so we get plus or minus 5 there. To get x by itself, I subtract 2, and I get negative 2 plus or minus 5. So to get my values here, I'm going to take negative 2 plus 5, 3, and I'm going to take negative 2 minus 5 and get negative 7. So 3 and negative 7. So again, I write my perfect square trinomial as a binomial squared, take the square root to get rid of the squared, then add or subtract to get x by itself. Now feel free to pause here and give this a try if you'd like. Again, I have a perfect square trinomial. X times x gives me x squared. 7 times 7 gives me 49. X times 7, 7x, doubled is 14. So this is a perfect square trinomial. It's x minus 7. We always take the sign in the middle there. Squared equals 25. To get rid of my square, I take the square root of both sides. And now my square and my square root kind of cancel each other out, and all I have left is x minus 7. Square root of 25 is plus or minus 5. We add 7, and I get 7 plus or minus 5. Again, the plus or minus goes with the 5 there. So my two options are 7 plus 5 and 7 minus 5, which gives me 2. So here x was 12 or 2. And we can plug those back in to check them. So if x squared plus bx is not part of a perfect square trinomial, we can turn it into one by completing the square. If we look on page 235, we have a take note there. We can form a perfect square trinomial from x squared plus bx by taking our b, halving it, squaring it, and adding it to both sides. That allows us to write it as a binomial squared. Every single time when we do that, whatever we got when we took b divided by 2, that goes in my factor. So here we want to know what value completes the square. Make sure that it's in the form x squared plus b to the x power first. No number in front of our x. Then we take our b value, half it, and square it. And 25 is what I can add here to make this into a perfect square trinomial. So we want to know what value completes the square. 25. Now, feel free to pause here and give this a try if you'd like. Again, in order to complete the square, we make sure it's in the form x squared plus b to the x power. Again, nothing in front of our x squared other than 1. Then we take our b value, half it, and then square it. And 9 is the value that we can add here to make this a perfect square trinomial. So again, our goal here is to be able to factor this down into a perfect square trinomial, x times x 3 times 3, so x plus 3 squared. And this comes from b divided